In this video, we're going to discuss the topic of classification of matter, a relatively simple process of putting all types of matter into one of four main categories. Our discussion today is going to result in a flowchart that you're going to make, which will allow you to make the decision of which of those four categories any type of matter could be added into. Before we begin, let's do a quick rundown of the learning objectives for today. First of all, you need to understand what it means to classify matter. We're going to go through a couple quick definitions. And then once you understand the meaning behind it, we're going to talk about the ability to actually classify the matter into those four categories. And those four categories are going to be mixtures, solutions, elements, and compounds. But we'll list those again a little bit later on in the discussion. Let's talk about the actual definition of what we're dealing with here. And we're going to break the term down into two parts here. The first part being classification. A very quick definition of classification is to group things into categories based on their characteristics or properties. And this is something science does in lots of disciplines, and this is something people do on a day-to-day basis, sometimes for good and sometimes for bad. But again, it's just the act of grouping things into different categories. Matter, then, is something you've hopefully discussed in previous science classes, is basically all the stuff that makes up our universe. Anything physical, anything that you can touch or anything that you can feel, we can jump into a category. So as you can imagine, this covers a very broad range of materials, pretty much everything that we have. Our job is to take that big group of everything and separate it into our four main groups, which again, and this is the time you should probably write them down, are mixtures, solutions, elements, and compounds. So every time we do this classification process, you should end up with one of these four answers as the potential conclusion for what it is you're discussing. Now before we move on, just a quick recap of the definition here. Classification of matter then is the combination of these two definitions right here. Classify means to group, and matter is all the stuff in our universe. So when we want to classify things, it's a matter of putting all of this stuff into some sort of different group. And again, we outline what those four groups were right down here at the bottom of the screen. As I mentioned back in the beginning of the video, now the step we have to take in is how do I get a sample of matter into one of these four categories? And that's where the flow chart we're going to be talking about before is going to come into play. On the next slide, we're going to put that flowchart together, we're going to construct it, and then from that flowchart we'll be able to make decisions as to which of those four categories we're going to be dealing with. So, we're going to start at the top of our flowchart here. We're going to start at the top of our flowchart here with the biggest category of all, and that is going to be all matter. So we'll put a circle around that, and that is the least categorized as possible, the least classification. Now all matter can be separated into two main categories, and as I said, this is going to be making a lot of decisions, and the first decision you're going to make is with these first one. All matter can be described as being heterogeneous matter, and matter can be described as being homogeneous matter, and we'll put circles around each of these. I'm going to try and color code this process as we go along to keep things separate. But our first decision you have to make is whether your matter is heterogeneous or whether your matter is homogeneous. Now before you can make this decision, we do have to know what each of these terms means. So let's start with a definition of heterogeneous. Heterogeneous matter is any sample that is made of two or more ingredients that can be combined but remain distinct from one another. So with heterogeneous matter, we can put these two things in the same container, but putting them in the same container does not necessarily mean they combine into one new substance. A wonderful example of that would be oil and water. Oil and water you can put in the same container, but they remain distinct. You can still see the oil, you can still see the water. Likewise, water and sand is another great example. You can put them in, you can shake it up, you can do whatever you want, but you'll still see the sand as separate from the actual water. Now, homogeneous matter is obviously the opposite of that. Homogeneous matter is any substance where all parts are identical. Any substance where all parts are identical. A good example of this would be like a marshmallow. You could take that marshmallow and you can cut it up into little pieces, and each little piece is going to be made up of the same exact stuff of the piece next to it and the piece next to it. It's a very homogeneous form of matter. A glass of water is another example. Every teaspoon of the glass of water is going to be exactly the same as the teaspoon of the next teaspoon of glass of water and the teaspoon after that, and you can do this over and over and over again until you get pretty much what you're looking for. So this is the first decision you make. The good news is that if you describe a substance as being heterogeneous, that brings you to only one possible conclusion. There's only one sample you can do with that, and that is something we will call a mixture. And I'm going to try and reserve this red color for what we will call our final steps in the process. You recall mixture was one of the final steps in the process. This is one of the categories you should end with. If you're not using colors, I'm going to put a little star next to each one of these as well, and that's going to allow you to, again, make that choice and recognize that this is a place where you end. We don't need to define mixture because it's going to have the same exact definition as a heterogeneous substance. And in fact, the word heterogeneous and heterogeneous mixture are going to be used pretty much interchangeably. So that's one of our first classifications. So we're already a step on the way here. Now, if you decide your substance is heterogeneous, you're done. If you decide your substance is homogeneous, obviously we have a little bit more work ahead of us. So that's going to bring us to our next decision that you would have to make. If you decide your substance is homogeneous, it is either going to be a solution. Again, notice I'm using the red here. That's one of our endpoints. Or your substance is going to be what's known as a pure substance. Now, if you decide your material is a solution, you're done. If you decide it's a pure substance, we're going to actually have another round of steps after this. But before we get to that, let's get a quick definition of each of these so that we know how to make this particular decision in the process. A solution is made of two or more ingredients that combine to form one new substance. So two or more ingredients that combine to form one new substance. A great example of this would be sugar and water. Unlike with mixtures, the pieces stay distinct, they stay separate. With solutions, they combine in a way that makes one new thing. Sugar and water combines together. The sugar will dissolve and create sugar water. You don't see the sugar anymore and you don't see the water anymore. All you see is the combination of the two of those. And anything you can combine like this. A lot of beverages, for example, fall in this category. Chocolate milk is an example that gets brought up a lot. You have milk and you have the chocolate syrup, and they combine to make one new solution. Crystal Light, any kind of powdered drink kind of thing, same thing. You get the powdered Crystal Light, you get the water, they combine together to make one new solution. So that's how we would characterize something as a solution. A pure substance is nice and easy to find because it's pretty much what it sounds like. A pure substance is made up of only one ingredient. There's only one thing in a pure substance, hence the name pure. And that's actually the way you'll decide between the two of these. Are there many ingredients when you have a solution, or is there only one ingredient, which means you're dealing again with a pure substance? So, if you decide your substance is a solution, you're pretty much done. You can call it quits. If you decide it's pure, as I mentioned before, there's one more step in the process we need to make. Pure substances divide once more into two more categories. We have, and I'm going to go way over here so we have some room, we have elements and we have compounds. So we have elements and we have compounds. So again, just like before, if you get to this point, you're going to have to make a decision between the two of these. So let's write down what some of the ideas are to how to make that decision. Oh, before we do that, let's put in our stars, right? We said we would star these. So there's a star for both of those, and then like I said, let's come up with a definition. Elements are what they sound like. You've learned in previous science classes what an element is. Any substance you'd characterize as an element is basically made from only one type of atom. And you should be able to find this atom somewhere on the periodic table. So if I name something as an element, it should be listed somewhere in your periodic table. If it's not listed on the periodic table, it's got to be one of the other three categories, and it's most likely going to be something that we call a compound. So let's define that really quickly. Compounds are made for two or more types of atoms that are chemically bonded together. I ran out of space there, but we made it. Two or more types of atoms that are chemically bonded together. And this actually is one of the hardest categories I find to identify because people have a very tough time telling the difference between something that's a compound with its two ingredients, quote unquote, and something that's a solution. The best tip I can give to you is that you've already decided your substance is a pure substance. You can't get back to the solution thing. If you decided it's pure, it's either an element or a compound. If you can find it on the periodic table, it's an element. If you cannot find it on the periodic table, then it must be a compound. So don't allow yourself to get fooled and somehow sneak your way back to the solution type of thing. Pure substance eliminates solutions, and you're stuck with one of these two options. Also, as you get better with this material later in the year, as you get more experience, this decision is going to be much, much easier because you'll have experience and familiarity with elements and familiarity with a lot of compound names, and you won't have to make that kind of confusion later on. You'll be able to just make this choice. This is pretty much the plan. Before we wrap things up, all I want to do is really quickly talk about, maybe do an example or two so you can see what's going on. And a wonderful example I think that we can try would be corn syrup. I think is a great example that we can use. Corn syrup, if you've never seen it before, is a thick, syrupy kind of substance, and it's used a lot in cooking and baking as an alternative to regular old sugar. Well, if you had a sample of corn syrup in front of you, you'd be able to look at it, and the first thing you'd have to do is decide whether it's heterogeneous or homogeneous. Corn syrup, like I said, is a lightly colored syrup, and if you took a spoonful out of it, that spoonful would look the same as the next spoonful, as the same as the spoonful out of that, meaning that corn syrup is a homogeneous substance. So we're going to move this way down our flow chart. We're going to move towards homogeneous. Now once we decide it's homogeneous, we got to make the next decision. Is it a solution or is it a pure substance? Well, to do this, we need to know if it's made of two or more ingredients or if it's made from just one ingredient. And you can do that by looking at the actual label. You'll see that it's made of a couple different things, being corn syrup itself, water, and a couple different types of syrups in there to make things, which means that it is made of multiple ingredients, which makes corn syrup a solution. Once you identify as a solution, that's it. We're done. We've made our identification, and you are ready to move on to the next sample to categorize. When we get to class, you're going to have a chance to categorize a lot of different substances, so you're going to get a little experience with this. And I think you'll find that by the time you're done with this process, you won't need to use the entire flow chart anymore. You'll just have an idea of what each of the four is, and you'll be able to do this very quickly.